welcome back to another video of LeetCode Daily Challenge Streak series, and in today's video we have a new question that says evaluate reverse polish notation. Now, what is a reverse polish notation? It is nothing but a postfix notation. Okay, it is nothing but a postfix notation. Now, what is a postfix notation? It is a mathematical notation in which the operator follows the operand. It means that in a given stack of elements, the operands are written first, then the operator, and then we'll perform the operations. So for example, if we consider 2 plus 3, we'll get 5. But what happens in postfix notation? Instead of 2 plus 3 here, we will have 2, 3 plus. So we have the operands here and we have the operation here. So whenever we encounter an operand while moving forward, we stop right there and we go back and take the required number of elements to perform this particular operation. Since addition is like a binary operation, you need 2 elements to perform this operation. So you go back and you pick 2 elements and perform that operation. So this basically uses a stack. Okay, this is like a stack based algorithm where whenever you're solving a problem, say 2, 1, 3 or plus or something. So whenever you come across an operand is nothing but the number that you're applying the operator on. Okay, and this plus or minus or division multiplication is called operator. Okay, and this is called operand. Okay, let's consider this example 2, 1 plus 3 into. Okay, now let me just write the elements down. 2, 1 plus 3 and multiplication. Now, what do we have first? What did I tell you? Anytime we come across an operand, we will just push it into the stack. I'll tell you what happens when we come across an operator. Now 2 is an operand, so push it into the stack. Next, 1, push it into the stack. Next, what is it? It is an operator, not an operand this time. So for addition, how many elements do you require? Since all of these, so for the problem that we are solving, we are only using binary expressions as in binary operators. So we only require 2 elements to perform these binary operations. So we will just pop out the last 2 elements that have been added, because I told you that the operands are the operands are followed by the operators are followed by the operands. Okay, so if it's 2, 3 plus, it means that this operator has been followed by the operands. So the answer will be 2 plus 3 equals to 5. Okay, this postfix notation is also called as reverse polish notation. Okay, now 2 and 1. So we got a plus now. So what will we do? We will just pull out the last 2 elements. So it's 2 plus 1 equals to 3. So since we have popped out these elements, now we currently have an empty stack. After solving this 2 plus 1 element, we will append it back to our stack. Okay, we will append it back to our stack. Now, what do we have next? We have when we go to the next element after solving this, we have an element 3. Okay, now this is your operand, so you will add it back to the stack. Now next, what do you have? You have a multiplication operator. Now whenever you come across an operator, what you will do? You will just simply pop out the elements from the stack and apply the operation that we are at. So since it is a multiplication operator, so it is 3 into 3, which is 9. So the solution for this one is 9. Okay, now let's take a different example to understand this problem more clearly. It is, let me choose a different color. It is 4, 13, 5 divided by n plus. Now we have a stack. Now first we are at 4, so we'll append it. Next we are at 13, we'll again append it. We are at 5, we'll again append it, because we didn't find the operator yet, we are still at operands, so we will still append it. Next, what happens? We came across a division symbol. Now that we have come across the division symbol, what we'll do? We will pop the last 2 elements. Okay, whatever number of elements are needed, how many ever elements are needed for that particular operation, we will pull that many number of elements out. So for division, we need 2 elements. So we'll pull this out and we'll pull this out. Okay, so we popped 5 and 13. Now what we'll do? We'll perform division operation. So 13 by 5. Now remember that in the question it's given the division between two integer always truncates towards 0. It means that anytime you perform this division operation, you should only get the answer, as in you should convert it into int. Okay, you should not consider the float values. You're only supposed to get the int values. So 13 divided by 5 will give you 2. The actual original answer will give you 2.6, but since the condition in the question says that it should truncate towards 0, as in it should be an int, you should only consider the int value of it, which is 2. Okay, now what happened? You divided 5 and 13. Now since this has been popped, what will you do? You will add back 2 into this. Okay, next you will move forward and then you have an operation plus. So what will you do? You will again pop 2 elements out. Now this time what you have 2 and you have 4. So you will simply add 4 plus 2, 6. After adding, what you'll do, again you will pop it back, 6. In the end, you will just return whatever element is left in the stack. Okay, after performing all the operations, you will just keep appending the result back to the stack, and in the end, since after performing all the operations we'll be left with one element, we are going to return that. You can either return it as stack of 0 since it's the first element and only element present, or you can return it as stack of -1 since it's the top element and the only element. It doesn't matter, it's your wish. Okay, so let's quickly code this up. We have a function evaluate, reverse polish notation, eval RBN given, in which we'll have tokens as in these tokens. Okay, now what are we doing first? Let's create an empty stack to append our operands. Now after this, we are just iterating over these tokens. Okay, so for token in tokens, now we have two conditions. We can either come across the operand, or we can come across an operator. What if we come across the operator? Okay, what if we come across the operator? If token in, as in if this token is either addition or subtraction or multiplication or division, what are we doing? We will pop the previous two elements out. Okay, we are popping the previous two elements out. So b comma a is equals to stack dot pop comma stack dot pop. Now why did I write it as b comma a? Because if you carefully look at it, when you are appending it into a stack, what will we have here? Let me write it down. So you have appended 2 first and then 1. Now when you see it vertically, this is the one that is at the top, okay, currently, and before that it is 2. So the one that you pop is b, which is 1, and the one before that is a. So 2 is a and 1 is b, which is why you've written it like that. Now what are you doing after popping? You're simply checking what the operator is. If token equals plus, what are you doing? You're appending the result of the operator value. Okay, so you will just append 2 plus 1 value. Okay, so stack dot append a plus b. Okay, you're performing this operation and appending back into the stack. Now else if token equals minus, as in now you came across a subtracting operator, so you will append its result. Okay, a minus b. Likewise, if the token is a multiplication operator, okay, if it's multiplication operator, then what? Okay, you can use anything, it doesn't matter for this question. Then you will stack dot append a into b. Okay, otherwise what if it's division? Equals to, if it's division, since you should have an int value, okay, since you should have an int value, you are going to append the int value of it. So int of a by b, you're going to append the int value. Now we finished the conditions for what if we come across an operator. Now what if we come across an operand? If we are at 2, what are we doing? We are directly appending the int value of it into the stack. Okay, else we are directly appending stack dot append int of token. Okay, since the particular element is tagged as token, in this loop we will append it. Now in the end, what are we returning? We are just returning the element that is on the top. So we'll return stack of 0. It's the first element and only element, so you can either return 0 or you can either return stack of -1. So let's quickly run the code. It's accepted. Let's just submit it. It's submitted. All right. Thank you guys.